Okay, let's look at this one here. So Carla decided to turn her attention to guys, I'm talking, thank you. Turn her attention to rectangles, knowing that a rectangle is defined as a quadrilateral of four right angles. She drew a diagram at the right, so A, B, C, D. You see the rectangle right there. After some exploration, she conjectured all rectangles are also parallelograms. Okay. Help her prove that her rectangle ABCD must be a parallelogram. That is, prove that the opposite sides must be parallel. Okay. So here's what we'll do. We're given that ABCD is a rectangle. I'll abbreviate it like this. And we're asked to prove that AD is parallel to BC and AB is parallel to DC. So actually, you're proving two things. First off, we need to state our given, right? So just kind of repeat what I just wrote for the given. A, B, C, D is a rectangle. Given. Two. Yeah.
Is it like A, B is parallel to DC?
Well, before that, we need to say they're right angles.
Oh,
Yeah, because we're not ready to say that yet, because we have to probably use like some sort of alt interior or same side interior, something like that, right?
Definition.
yeah.
Rectangle that's parallel.
Let's say we didn't know that. Let's just say we didn't know that. No, you are correct. It is defined as a parallelogram with all, but let's assume we didn't know that. So it's just a quad, or you have a quadrilateral for right angles. Let's say that, right? So that's the thing. That's gonna be definition of rectangle. But you guys are right. I mean, you're not wrong in saying that. Now here's the deal. Angle A and B are supplementary angles. You guys remember what supplementary means?
Green.
Add the 180. Thank you, Cam. So they add the 180. So I would then say definition of supplementary angles. I could get a little more detail if I wanted to and say, oh, angle A, B, C, D are each 90 degrees and A and B up to 180. But I think we could skip to that. Definition of supplementary angles because they have to 180. So then you could say this. Angle AD is parallel to BC. And that's because lines are parallel when same side interior angles.
Is this like another CP?
No. It's you guys have done in the past like when alternate interior angles are congruent, lines are parallel. So there's no triangle congruence going on here. And by the way, if I do step 5 and step 6, I'm going to also say definition of supplementary angles. And number 6 will be same as number 4. Angle C and angle A and D are supplementary angles. And of course, AB is parallel to DC. So let's kind of look at one more time. Need to put these little segments here. Yeah, let's look at one more time. I probably could have done this in 4 steps, to be honest. I probably could have went 3 and 5 is 1 step, and 4 and 6 is 1 step. So it's being a little more detailed than I need to be. But if you're told ABC is a rectangle, and again, you guys are correct. If you're told it's a rectangle, of course it's a parallelogram. A rectangle is a parallelogram. The special, where all the angles are the same, they're all right angles. But let's say you didn't know that. Let's just say, oh, it's just ABC is a quadrilateral, 4 right angles. Fine, that's all you know. Then fine. If we're given that, then we're going to say that ABCD are right angles. And you should technically say, oh, they're all 90 degrees. Oh, then these two have 180, and then oh, these are supplementary. I just went straight from 2 to 3 and say, you know what? They're still their angles. Great. But so are A and B. And if that's true, then you have lines that are parallel, because that's a thing we've talked about in the past. When 2 lines are two angles are supplementary, and they're on the same side, on the inside, at 180, lines are parallel. So it's just another proof to kind of prove that some quadrilaterals have some sort of behavior. So that's what's happened. So yeah. Okay. No, the quiz. It's just triangle still. Yeah, the quiz. Actually, we could talk about the quiz after I finish this. I can kind of direct you. I think all the practice I provided for the previous quiz, was there some delta method? I can't remember. There was some practice I did provide, I think. I think it should be still applicable, I think. It's sort of to the group quiz, it's individual this time. So that's all. But I'm pretty sure there's something in delta math I had. I could check. All right, let's keep moving. Okay. All right. This one I like a little better. Because I don't want to do any more proofs for a little bit. Okay. For each diagram below, find the value of x if possible. If the congruent, state which congruence condition you're using. If not, or not information, then of course say so. A full proof is not necessary, but let's just at least put our reasons down in some bullet point format, right? So if you think about it, let's call this D, by the way. What can we say about triangle ADB and triangle CDB? They're both right triangles, but also congruent. Yeah, also you could say side angle side. And why? What's true about AD and DC?
DC.
Yeah, because they show that by the markings, right? That was given. BD equals BD. Why is that? So it's reflexive. And angle ADB is going to angle CDB, because what's true about each of them? They're both what? Yeah, there you go. So without actually doing a formal proof, you can explain to me using some logic, right? Actually, if you want to put a formal proof, it's not that bad. Step 1, AD is congruent to CD. Step 2, BD will be reflexive. Step 3, right angles congruent. And then step 4, SAS. So we're totally fine. So in this case, I know that's 10. And that's kind of a CPC-TC thing. So how do I solve for X now? What do I do? Yep. Texas 6. Okay, good. All right. Why don't you guys try BCD in your partners or whoever you're sitting next to, you can do on your own if you want to work solo. Um, and we'll talk about the reasons as well. Then we'll do another proof. And just kind of keep things moving. I do want to do 724 as well. Because the other class did a quiz today. So yeah. So go and do BCD. We'll check in about 3 or 4 minutes. I'll do as well.
Wait, and we can just do like a bullet pointed thing.
And then. You guys.
Niner scored.
Got 4-6. This isn't even good. That's just like small margin.
Exactly.
Like it's.
A loss is a loss.
Oh.
If you're not first, you're lost. That makes no sense, but.
Needs to be
What?
punished.
No, it's your.
I'm gonna bend this to my one.
The warrior gets stuff.
Oh, Jimmy Butler hurt. He's out now. Great. What's going on with all these Bay Area athletes getting injured? Oh, boy, sorry about the Bears, dude. That was a. You're right. You're in Chicago?
Yeah.
You in Chicago on Sunday? That's crazy. How cold was it? Oh my goodness, that's cool. I mean, no pun intended, but yeah, that's. So you were able to see that pass? That was impressive.
Yep.
The broadcasters kept saying like, this place would go bonkers if like Bears could win this game and tied the game, and yeah, I was actually rooting for the Bears at that moment. Yeah, at that moment I didn't want them to win.
Rams and Seahawks go to the Super Bowl.
I think it's gonna be Seahawks Patriots. That's my pick now. Yeah, but not good without Bo Nix. That's not gonna happen. Actually, it can. Backups have won Super Bowls in the past. Nick Foles, but he actually was a backup for a good portion of the season. But in New York Giants, in 1990, they won with a guy by the name of Jeff Hostetler, beat the Bills. And even the Bills, I wanted them to win. Like that was another one. Like I was really sad to see. Like, yeah. I call it like the weekend of it's a Greek tragedy of quarterbacks. Just yeah, just sad. You guys keep working. Yeah. Yeah, Colette.
What are you talking about? Bro, I haven't seen a playoff one in my lifetime.
I was.
You never seen the Bears win a playoff game? You will. You will. When you do, it's my first one I saw in person was the Niners against the Saints in 2011. That was like the most spectacular finish. And we were going bonkers. It was so much fun. Yeah.
I was like too young for it.
See, when I was in the sixth grade, the Niners won a Super Bowl. Then the following fall was the Babe Ruth World Series between the A's and the Giants. Then the 49ers repeated. And then the Warriors had like it's pretty fun 3 players, Tim Hardaway, Chris Mullin, Mitch Richmond. They call it Run TMC.
Oh yeah.
Yeah, and then the Sharks were established that year. Then the A's won 3 straight American League championships. That was a good time to be a Bay Area. There was a lot of good sports. 2010 was pretty good. Stanford was doing well, and yeah, those were some good times.
And like, not right. I just like, so it's not.
So like if you got that, you can. What? If you want that from them.
Someone calculator borrow.
That's like John.
Wait, he was like the starter.
Yeah, we're not.
Joe had tons of stuff. Writing things. I like this.
How the Dodgers like just keep getting better? They're now the best closer.
Yeah.
They have that one of the best center fielders. Like they're just like, yeah, they didn't lose anybody. Yeah, it's like, yeah, the best player probably since Babe Ruth. I mean, yeah, it's like, yeah, they're just it's almost not fair.
Thank you.
All right, guys, here we go. So I think Salon for X should be pretty straightforward. Like, I think obviously B is 10 and D is 4. I don't think that's that hard. C, just make sure you guys remember your trig, just old stuff. Tangent, you can do tangent 35 degrees equals 11 over X, because it's also 35 degrees. And why are these true? I didn't get too detailed C or D because I got a little lazy. But for B, hopefully you can see that there's an ASA situation, because these angles, I'll use a different color for a bit of contrast. This angle is same as that angle, right? Those two angles are the same. ABD, CDB, same, right? And of course, they share BD, so that's reflexive. And of course, angle ADB and angle CBD are given. So that's for ASA. So that's how I could say they're congruent, and I could deduce that X is 10. For C, I could deduce that triangle ADC and CBA are congruent by HL. They share the hypotenuse, which is AC. They share a leg, and of course, they're both right angles. And tan 35 degrees, 11 over X, work it out. So you got that. Because you could use your CP/CTC to say that ACD is the same as CAB for the angles. And for D, that's an AS because you have vertical angles, first of all, going on. And you're given that angle A and C are the same. And also, we know actually, wait one sec. I lied. I am not being honest with you guys. We don't know.
Why?
AA is not a congruence theorem. I don't know anything about the sides. It's drawn that way. Here's the thing. All I know is that angle A is the same as angle C.
Really?
We don't, because all we know is angle A is congruent to angle C. And angle B is congruent to angle. That's all we know. We don't have enough information. Sure, you got vertical angles. You got that too, but we don't know. A is not a congruence theorem. So it's not.
Wait, but since it's vertical, so you know that has to be the same as 4.
No, because it could be. It could have been this.
Oh. I don't
What if you had that, guys? That still would have been fine. That still would have been legitimate. Doesn't matter. That's similar. They're similar, but the sides I don't know. All I know is the sides are proportional. But are you given any other sides? That's why. I know it's the trick. I fell for it. Hey, I caught myself. I'm glad. But yes, I fell for it. Yeah. Of course, yeah.
For
Yeah.
C,
Hmm?
do you know that the lines are parallel because of like right angles? And
Correct, but it was more so we have two right triangles and they both have the same legs and they share a hypotenuse. That's my reason why.
So we know they're the same.
So it's the same triangles, and then
Yeah, like-
therefore
That's why.
30 both 35, correct, right.
Could you also just say like if there's four right angles and like the thing they do.
Sure, then the sides are same, sure, do all that stuff, yeah. Okay, let's do a formal proof again. Yeah, go ahead, yeah.
The other, like the angle DCA is 35, there's no like parallel line things, we just had to go through a whole.
For which one, sorry?
How do we like, for the angle ACD is 35?
Because these triangles are congruent. This is the same as this one.
Oh, does it tell?
Well, we deduced that because we know these are the same. These are the same, and they both have right angles. So it's HL, hypotenuse Lake theorem. That's why. Yeah. Okay, let me redraw part B, and we're gonna prove down below. So I'm gonna redraw it because we need this at our disposal.
Or maybe that's.
Okay. So let me move this off to the side. All right. So our goal is to prove, I don't know how many steps we're gonna have. Our goal is to prove that AD is congruent to CB. So what are we given? We're told that AB is parallel to CD. That's given. Also, we're told that angle ADB to angle CBD. Okay. Remember we said BD is congruent to BD? What was the reason for that again? Reflexive. So we're just doing part B in a formal proof, that's all. And when line AB is parallel to line CD, what two angles are the same? Yep, is congruent to. Correct. ABD is the same as CDB. Either way is fine, how you say it. And that's because alternate triangles congruent. And I do need to move this. It's going to be a 5-step proof. Then I say triangle ABD is the same as CDB. And that's because of ASA. And then lastly, CP/CTC. So again, just more review of old stuff. But what does prove to us is that I believe this is a parallelogram, right? We have that going on as well. We're going to talk more about that later. But again, we prove that AD is congruent to CB because we prove the triangle is congruent by ASA, and then how the triangle is congruent because of all these other things we just said. So, questions? No? Okay. We'll move on. Yeah, of course. Also move on to the next section so we don't fall behind because we have time to do so. But I'll make sure you guys have time to work on homework too. I have printed the homework, so I'll give you guys a handout for it in a moment when we finish next set. Okay. Let me freeze this. Okay. We still got a couple more pages of notes to do. Now I feel like we're in a good spot. Okay. Just give my voice a little break. So have some do some reading. Mag, can you read the opening paragraph where it says more properties of quadrilaterals in 7.24?
Remember to ask yourself and your teammates questions such as, why does that work? And is it always true? Decide whether your argument is convincing and work with your team to provide all the necessary justification. By the end of this lesson, you should have a well-crafted mathematical argument using something new about a familiar problem.
Cool. All right, thank you. So let's look here. What else can congruent triangles tell us? Your task, we're not going to do poster paper, but we'll just talk through it. For each situation below, determine how congruent triangles can tell you more information about the shape, then prove your conjecture, means your theory. Be sure to provide a reason for your statements. For example, if measure angle A equals measure angle B is not enough, you must give a convincing reason such as because vertical angles are congruent, blah, 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 or because it's given in the diagram. Use your triangle congruence conditions to help prove that triangles are congruent. Later, teacher will select one of these proofs for you to place on a poster. No, I'm not going to do it right now. On your poster, include diagrams, statements, and reasons. Fine. Clear state you are proving and help the people who look at your poster understand your logic and reasoning. I think that's what this project's about, but we'll do that later. Let's just go through these examples here, and then we'll be done. So in chapter 1, you use symmetry of an isosceles triangle to show that the base angles must be congruent. How can you prove this result using congruent triangles? Assume AB and CB are the same. With your team, decide how to split triangle ABC into two triangles that you can show are congruent to show that angle BAC is the same as angle BCA. All right. So what we're going to do is we're going to do this. We're going to cut that. And we'll actually do a formal proof. I mean, it's kind of long, so I have enough space here. Statements and reasons. All you know so far is that side AB is congruent to side BC. That's given. This we know. We want to prove, I don't know how many steps we need, that angle BAC is congruent to angle BCA. Okay, Faith, go ahead. Yeah. Correct. Yes. Yes. Yeah, we did a long time ago, right? We forgot. Right. Correct. So here's the deal. Let's introduce a new letter. So if we introduce that, what can you say about BD? Actually, before we even do that, let's state that BD bisects AC because you said you're told to do that, right? Split into two triangles. So say BD bisects AC, and that'll be given also. So that should be given to you because you're providing that, right? Okay. What do you guys think next? What should we do?
Angles.
Okay, good. BD equals BD for what reason? Okay, let's get that out of the way. And if BD is bisecting AC, yeah, exactly. And what's the reason for that? Yeah, good. You could say we're not going to do perpendicular lines because I didn't make that statement. So AD is congruent to CD, and that's right definitions. And you gotta say segment bisector. And actually, I think I graded your quizzes already, so I can actually hand it back today. Yeah, I think I already put them in Schoology as well. Um, yeah, definition of segment bisector, right? So you gotta say segment bisector. You gotta be very clear about that. And then we could say, I don't know. I feel like I'm doing all these colors. It's kind of fun. Going kind of crazy in colors here. So then you can say triangle ABD is congruent to triangle CBD. Yeah, good. So we went up doing ourselves a 6-step proof. And then lastly, CPCTC. So yeah, so that's how I can prove that the angles opposite congruent sides are the same. So what we just did, hold on a sec. Let me hold on, get Reagan. What we just did, we just proved that the angles opposite congruent sides of a right triangle are congruent by using our knowledge of congruent triangles. That's what we just did. Reagan, go ahead, you have a question.
Yeah.
I don't think so. I could look. Hold on.
I go for Magna so yeah,
So dumb.
No.
The quiz, there's gonna be ones where it's like, you tell us the shape and then we have to do it.
Yeah, I know it's gonna try. I just
Okay.
That's not triangles.
I generally don't think about.
Yeah, I'll pass my quiz guys. So
I don't think this one was very high.
okay, guys, let's keep moving. June's great on time. Okay, so let's keep moving here. All right, part B. And part C. So I'm gonna tee these up for you guys. So what you want to do for part B? You guys quiet. So again, so we got 2 more proofs and we're done. What can congruent triangles tell us about the diagonals and angles of a rhombus? Okay. Examine the diagonal of the rhombus to the right with your team. Decide how to prove the diagonals of a rhombus bisect the angles. That is, prove that angle ABD is the same as CBD. So you want to prove that these are the same. So in order to do that, this is what we have to prove. So I'll tell you what you're given. You'll just do it. So since it is a rhombus, I'll kind of just tell you the sides, just kind of make your life a little easier. So we know that sides AD is congruent to side AB, is congruent to side BC, is congruent to side CD. And we'll say that's given. And what you want to prove, might be able to do in 3 or 4 steps, I think. You want to prove that angle ABD is congruent to angle CBD. Yeah, it should be actually, it's a 4-step proof. Yeah, it's 4 steps. Unlike some of the crazy ones we did the other day. Yeah. Okay. So we're gonna work that out, fill in the blanks. Statements 2 and 3, reasons 2, 3, 4. Of course, yeah. And then I'll check in about a couple minutes, and then we'll do last proof together. Then you guys can start homework.
Side is.
Yes, that's actually gonna be it. It is sick. I'll give you guys another minute. Should be a pretty fast proof. Yeah. Okay. You guys get that? We're good? Yeah. Again, pretty straightforward. All four sides are the same. So you definitely have your two pairs of congruent sides. You add a third pair of congruent sides, BD being equal to BD using a reflexive property. Therefore, you can say triangles congruent by SSS, therefore CPCTC. We can deduce that ABD is the same as CBD. So what this tells me is that in a rhombus, the diagonals will bisect. Oh, they're terrible.
Score, right?
Right.
Actually, I thought I had 2017 Rams Chicago, but it was a Houston New England game. So it was a 3-point win. Actually, I was right at the point total. The point total is 41-6 for San Francisco. It was 47 points. I just was off on the distribution of points. I didn't think the Niners were going to commit 6 turnovers. And Buffalo Denver, it was 24-22 late in the game. And then Buffalo scored a field goal. Then Denver scored a touchdown. The Buffalo scored a field goal, and then it went to overtime. And sadly, Buffalo just couldn't do it. So, yes, I love football, but I kind of don't care anymore now because the teams I was emotionally invested in all lost. So, well, I want to see Buffalo win because I mean they have never won a Super Bowl. No, I kind of just follow the casually. I didn't really. Yeah, I heard it was. Yeah, Lamont's daughter goes to Miami. He was really pulling for Miami, but he was upset. And yeah, in a rhombus, the dogs will bisect the angles, and we can prove this again by using
Being like the angles are equal.
our knowledge. Yes. Okay, so again, that's what's happening there. All right, one more, then we're done. And you guys have plenty of time to do homework. Let me freeze that. Okay, I'm gonna set up the last one here for you guys. I'll leave this up if you're still copying. So let me set up the next one. So we can do a 2-column proof for part C.
We have a lot of work tonight.
It's just one sheet, 2 sides.
One sheet.
I know. If you're still copying.
Okay. Find the one.
No, he wouldn't. But so he was. He should have just thrown him. If you have.
Good luck, you take some of them.
Should have just thrown
I
back.
think throw it out there, like, it's so big that it's in the skin. That's going to happen.
They get too hard.
Yeah. You can like stay on the lines in parallel as like.
I'm gonna do this instead. Hey guys, we're gonna switch it up a little bit for last proof. Okay, guys, quiet please. For last proof, here's what I'm doing. I'm gonna tell you that AD and BC are the same. I'll tell you that.
What's?
Because it's true for rectangles, right? We know that.
What?
It's okay. No, I'm sorry. I'm switching up. Sorry, Connor. Yeah, chill, dude. I'm actually making it easier for you guys, to be honest, because this would be a much longer proof the other way. They suggested. So let's say AD and BC are the same. Angle D and angle C are right angles. Okay, and that's given, of course. We know that. Another thing I did too is I redrew the diagram. I took ADC, kind of pushed off to the left. I took BCD, I rotated it just so that they're lined up or oriented in a similar way, right? So AD, BC, same. They both have right angles. So what we need to do is prove the triangles are congruent and then use a CPCTC at the end. So I think you guys should be pretty okay with this. So again, very short proof. But this is another way you can still use the fact they have a rectangle, because rectangles guarantee right angles and guarantee sides, opposite sides are the same. It guarantees that. So I just told you that straight up. But then we can use this to prove that the diagonals are the same. So go ahead and try that. That proofs, again, very short proof.
It's all, isn't it also within that thing, that you and BC are parallel and AD and B?
It's true, but we're not going to use that. You can. We're not going to use it. I don't want to.
Wait. There. Think like the ones like for the angle like the.
Yeah, but we're just proving that the diagonals are the same. That's all. So what I did was I drew the two triangles like that, ADC and BCD. And I know have two right angles are there. And I also know that AD and BC are the same. Because opposite sides of a rectangle are the same.
Sad. Property here of Lexima. In my foreign part, wow.
Oh, you did.
Yeah, sure. All right, we should begin this. So CD is congruent to CD, reflexive. You have side angle side. Actually, I should have said this. I should my apologies. I should have introduced one more step. We must also say that angle D, that's because right angles are congruent. My apologies. You gotta squeeze that in as well. Because I was looking for that in your proofs. Yeah. Then you could say the triangles are congruent by SAS, but
Oh, 'cause you just
I mean,
did
I
right
know-
angle, you didn't say
yeah, and you're not using hypotenuse Lake theorem also. So yeah, we have to use it because since we're using SAS, we need to make that statement. So it was actually a 5-step proof. Okay. So again, the takeaway here. Key takeaway. Diagonals of a rectangle are congruent, which we can prove using our knowledge of congruent triangles. I'm not kind of repeating myself here, but again, that's what we're doing again. Right. Yeah, now you know. Now you already know it. But if I asked you to prove it, this is what you have to do. But now you know. You guys want to be done? Sure.